Hello learners, this is continuation to part 1 of Complete Guide to Start with Embedded Systems as a Beginner. In the last part we have covered all important topics as who should opt for embedded systems, is post graduation really required to start with embedded, what kind of skills are required, important topics to be covered, importance of Linux, real-time operating systems and other concepts. Now in this part we will be covering some important aspects of C programming. We have special compilation of 300 C programming questions essential for embedded systems. We'll discuss some of those problems and problem solving approach as well. We will also discuss about projects for embedded systems and what kind of job roles are available in the market. So if you are a beginner, watch these two videos completely. They will enable you with all basics requirement to start as an embedded engineer from scratch. Ask as much doubts as you can in the comment section and we will happy to answer each one of them. Let's begin. So Yash, you have one PDF C for C questions, right? I have already used it and I find it very useful actually. So you want to talk about it?
Yeah, this is one of the things that I'm proud of. I could say that I created this, and I find that many people are using this and finding it very helpful. So the book name itself is Mastering C for Embedded. It's got like 300 essential programming challenges to elevate. They do not include the solutions, but the problems. Why I created this is one of the main reasons behind my C programming experience and my programming practice learnings. So when I searched about C programming as a beginner, I was okay with finding the material online, or when I was preparing for interviews, I was finding it difficult to relate them with the interviews. In the consider I learned or I have done a small project on C, or where I wrote about implementation of stack kind of thing. I don't know how that can be used in an embedded device. Can I make that program generic? I do not know how that works. Or if I went to the lead code, if I have done some problem on sorting of the red ball, blue ball, green ball. I cannot find the link between the program that I write online there and the program that I write when I work with the device. So I was finding that there is a gap when I search for the generic C programming and C programming related to embedded devices. I thought to explore. I explored all the resources, mostly all the resources available on the internet, to search for the programming questions that help me help my programming journey to gain my skills, so that the programs that I practice are also included in the embedded domain, are related to the embedded domain. So that is one of the most important concepts that I have prepared these questions. I didn't want like practice one question, search online for another one, practice next question. That's not something like that. And when I say practice, it's not like copying the solution as is, or understanding, not just understanding the solutions. It's like thinking the solution of your own and implementing the problem in your own way. So I have created this book, and it's got like divided into 12 different topics, from strings, arrays, pointers, structures, unions, all the way to Linux internals, bit manipulation, searching techniques, sorting techniques, memory management, many things. Each of these topics have 12 problems in them. And the problems are arranged in a way such that uh, you can just get started. If you're new to C, you can just take that book, you can download that, you can buy it from Amazon.
So you have solutions of these questions in your GitHub repository?
Few of them, not for all of them. My main aim for creating these questions for the GitHub was actually, once people just create a once they clone this repository, I wanted to see. I wanted for myself to see, and all others, like if there are 10 different solutions, 10 different solutions have 10 different approaches, 10 different problem solving skills, like the thought process behind this 10 different people on how it's solved. When a person like me, or if someone is new, reads that particular problem set, and once they are able to read these particular solutions, they can see how a single problem can be enhanced, or how a single problem can be thought of when they see these solutions, one can directly do it with the stack, one can do it with heap, one can consider the end cases, one cannot once or one just write a basic code. Once they read through this, any beginner reads through this, they know on how they could think for a particular problem. They would develop the skills for problem solving. That's the important point, that important aspect, that the reason that I didn't write solutions for these particular problems. Because if I write a particular solution, if I write, they would follow that solution. Like it stops their thinking.
So we'll put both the link for your repository as well and PDF as well in the description of this video, right? Let's move on to the next part of the video,
Yes,
and let's start discussing about how one should approach for embedded system projects.
yes, it's true. As you said, systems, anyone who's starting in the early career or who is already working in the field, it's pretty important to develop this project-based mindset. When we say project-based mindset, consider I give you you get starting with my Arduino microcontroller. The first thing that you do is write a Blinky program and test the features of that. You're good with that. Now you're interacting with sensors and some LCD screen, some motors, some push buttons, the PWM, I mean the pot meter and everything. These are the things or parts of programming them. Like you're testing if these are working or not. Now the next step would be, can you combine 2 to 3 different sensors and make that as a workable device, or some use case application? When consider you are using an LED and a pot meter, you're controlling the LED through the pot meter. Here, the concept of PWM comes. You need to consider the duty cycle. You need to make sure that when we lower the pot meter, the brightness lowers and it increases. That application can be like literally seen in almost everywhere. Like in our cars, if we want to reduce the brightness, we just push few buttons. It reduces the brightness of dashboards. Like this is a small, simple project with some applications is made into a bigger project in a different field by different field. When you develop, when you are adding 2 to 3 or multiple sensors together, multiple actuators together, you need to make sure that how can this thing or how can these devices be turned into a real project? How can it be linked to a real project?
Yeah,
Not
you mean to
replicating a
say,
real project. How can it be linked?
yeah, so you mean to say like start with individual component, let's say LED or any particular sensor, and then try to combine them to make one device.
Yes,
So yeah, there are
yes,
multiple good examples, but yeah, for the easy understanding, I'm considering it as a line follower. So you mean to say like just try to have 2 3 components in one project and try to build application using lots of components. So this might be the next step.
yes.
Okay.
Yeah. You can see my LinkedIn post where I've created a list of projects that you can begin with. And uh, they are pretty interesting projects, small 4 to 5 projects that are not restricted to a particular microcontroller. You can pick any microcontroller from Arduino to STM or anything, and you can implement those as projects. There and when I these are just microcontroller based projects. I also want to tell about a different kind of project that is software based. So consider you're working on Ubuntu itself. When I say we see the kernel space and user space basically. So system calls interact between these 2 segments. Just pick a particular system call. You can see my GitHub repo. I've implemented a small system called like stribrk. I replicated it and made it to strpbrk. It's a small modification, but it was a project on its own. Uh, I'd like to explain on how the project mindset like generated when I was working on this particular problem. stribrk is a small system call that searches for a particular first occurrence of a character in a string and returns that to the user. Here, I analyzed that problem thoroughly. I have read through the description of it. I've read few articles on how that exactly works, got a good understanding on how it works. Now, Now I wanted to replicate it. When I replicate it, I just don't want to give the like 100% replication. I just wanted to add one more feature to it, my own feature to it, so that it becomes a project of its own. So instead of just giving the character, I've also given the location of it, which character is found in which address or location in the sense at which letter. So we're having a few words in which particular position is that character present. I wanted to return that. In normal implementation, we have, I think, character pointed as return, but now I want to return both the character and the location. Now I need now I have two inputs, now two data types, char and int type. To return, I can't use arrays because arrays we can only use for homogeneous data types. But this one, I need to use structures. So I need to return the structure itself. So uh, here the entire return value is changed, return data type is changed. Now that's a new feature to this particular system call that's already existing. It's like you're implementing a new feature. And when you, what I've done was search for the first step was replicating the exact same working of the particular system call. If it searches for a string, searches for a character, the first occurrence, search for it and return it. That's the first step that I've done. In the second step, I've added the feature of my own. In the feature of my own, I removed the written part of the character written part and implemented the structure written part. I just search for the character. When I search for it, I go to another loop or I go to another function where I update the structure of the location and the character that I found. And in once the function returns after updating, it prints out the location to the user and also the character. So this is a new feature of its own. This took me like a couple of days just to analyze and do some thorough research and implement few safety features kind of thing. And now that became a project of its own. A simple function, a simple system call is now a project of your own. Now you can put that in resume, you can put that on your digital resume, you can share them in your LinkedIn feed, GitHub. Now, since you have made that, you need to learn. You are confident to answer about that in the interviews. You don't need to revamp or start something from scratch. You know how structures are used. You know how pointers are used in that. You can give a clear idea. You can tell a story to the interviewer on how you implemented the project. So this will help you a lot when you learn anything in the project-based manner. That's the point I wanted to say.
Okay. Yeah.
So as you can see on the screen for this problem, finding the kth max and min element of an array, the WTD, what to do, gives you a detailed description on what exactly the problem means. And this does not have a solution. You need to figure out a solution of your own. And as shown, where can we use this or where this problem can be used in the embedded system? When we read a temperature from a particular device, we constantly monitor it for like from 500 within 200 milliseconds. We'll be constantly monitoring it. We need to know a trigger point or a particular point at which particular temperature at which we need to trigger a particular output. Like if the room is too cold, if it reaches below, like consider uh, 25 degrees centigrade, then we need to switch on the air conditioning for cooling the room. So that output will be when the sensor reaches 25 and our program recognizes the 25 temperature input, it triggers the output. It then switches on the AC, air conditioning. And similarly for the cooling part. So this problem can be linked with that particular output example. So it's closer to embedded devices. And if you are able to accomplish to write this problem, you can literally build a small device. You can take DST 11, I guess, yeah, that temperature sensor, take some microcontroller, Arduino, or some microcontroller, and read the temperature from that every 200 milliseconds. Once the temperature reaches, put a flame near it. If it reaches uh, above particular temperature, let's say 40 centigrade, then you can just switch on a fan, touch another output device to particular pin, and just give it as a trigger. If that trigger is reached, while reading that, you can just write, you can keep an if condition. Here you have two options. Since I said it does not provide a solution, you can write a solution of your own. Here you have two options. Either you can keep a loop within the explanation. If this is reached, keep this interrupt, make this output as on, switch on this particular fan. Here you can see that every time the program needs to execute this particular segment of if condition, which may or may not be true. If it's running for 1 hour, it always need to check that every 200 milliseconds. That's going to consume a lot of CPU resources. Instead of that, here you can use the concept of interrupt. If that particular amount temperature is reached, you can interrupt the controller while it's performing some other task and say that, hey, now the temperature is 25. You can just switch on the power up this DC motor at this particular pin.
Okay.
Here you can see how this generic program can be modified into a particular embedded program itself.
Yeah. So
this is like again, as you can see, yeah.
Yeah, so yeah, pretty much interesting, interesting correlation between how simple programming questions can be used as an application in the particular device, like for creating a particular device or something like that, right?
Yeah. All of these questions are based on those particular scenarios. We can literally create a scenario for all these questions that are specific to embedded field.
Okay.
As you can see, one more question like moving all the zeros in an array to the left part. This particular scenario, we can say that it's like zero padding. If you get huge amount of data, you can just collect. If you have not just zeros, you can keep any particular, like if you want to filter out the digits 5, 6, you can. If you want to filter out digit 5, or if, let's say in this case, as you can see, if you filter out 0, you can move all of them together. Like if the collected data size is 500 and you got half of it, like 250 of it as zeros, you don't need to implement any search algorithm where you need to find all zeros and put them all, delete them one by one, and collect all of the remaining elements together. You don't need to do that. Instead, this would be a different approach. You search those zeros, push them all to the left. Whatever numbers are present in the same position, you'll be just collecting them onto the right. And you can just calculate how many zeros are there. You can create a new array, initialize the right segment, or you can remove all the you can remove the section from where the zero starts and ends. Keep the required values in the new array that you created. Here you can also see you're not using the 500 array size. You're reducing the array size to 250. It's like you're making the system more efficient and all in terms of memory. So this simple problem is also linked with that way. All of the problems are done in this manner, where you can think about a particular situation, and also this can be a project on its own. You can combine the previous two questions and create a project, like continuously read the data, filtering out if the temperature is 30 degrees, filter out all the 30 values, 30 numbers to the left, just see the right part. And this, it's like you're modifying this. The more you try to solve these problems, the more complex and interesting the problem or the project would become.
Okay.
And I've also written this.
In that way, you selected the problems in your PDF.
Yeah.
And
Yeah.
they should have some or other application in embedded system. So you thought like,
Yes.
what can be the application for this particular problem, right? So
yes.
Okay. Yeah, we can.
And this problems also gives me a motive. Like if consider when I want to search for these zeros, I don't want to do linear searching. I want to do some other searching. Now I need to learn some other form of searching, binary searching or any other searching. Here I have a need, like I have a motive to learn a new algorithm. Now I'm also learning the new algorithm and implementing it. When I implement the algorithm, I won't forget it. So it's like you have a motive to learn something.
Interesting. Yes.
Yeah.
Yes. So you mean to say we should have particular application, like we are trying to implement certain project or certain thing, so that in implementation we often do not lose the context, right? The concept behind it.
And also that was just for the arrays part. I've also have, as you can see on the screen, this is for the memory management part. This memory management questions, I say like they are, I say it's a wow kind of thing. It's a each question here is a complex project of its own. You can see like the segmented memory allocator, slab allocator, memory safety checker. These are crucial topics in the field of embedded. And these problems, I don't think I never found these concepts over the internet. I've collected all together. I've, I mean, these concepts, when you write device driver programming or when you're working with the OS, you will literally see how these concepts can be used over there. When we say slab allocator, in next they are using the slab allocator all the time.
Yeah, so
And when we
if audience is like, if audience respond to us, and if they are more interested to understand this problem, we can record one another video for them.
yeah, we can go through detailed steps of how this problem can be approached, the various ways, the possible solutions. We can give a detailed kind of thing for a particular problem.
Yeah. Yes, absolutely.
Definitely go through this PDF. It's so useful. And the memory safety checker is, I could say this is one of the best thing that one could implement as a project. Here in C, we don't have a memory safety checker. You just write malloc and you forget to create, that program goes on. Right? If it's a small program, okay, yeah, we can ignore it. But if it's program that has constant inputs of thousands, then you need to free it. You can't forget it. There you need to check for the buffer overflows, if it underflows. If you are trying to use that memory for some other function, you need to know how much memory to pass. If you here when you talk about memory, you get the concept of pointers, memory concepts, and pointer concepts is gonna cause a big blunder. You're gonna face a big disaster if you don't understand these particular concepts because try to allocate 500 bytes, but you try to get the 501 byte. Now you're causing a big trouble to your program.
Yeah.
You're trying to allocate 500 characters and you're trying to uh, get those locations using an integer pointer. That's going to cause another trouble. So these are some interesting concepts that you can implement in the project itself in the memory safety checker. And if you are able to complete these memory management questions, as you can see on the screen, it's going to be a like beautiful. I could say it's like a birthday present for the interviewer that you're going to you. They're going to be very impressed on the skills that you get when you solve these questions. And in interviews, you don't feel like I need to learn this concept or I need to study this. You'll be like, I know this concept. I can just go and share my experience. You'll be sharing your stories in the interview instead of just thinking about or becoming nervous about what to say. These are gonna this drive you crazy. I mean, in a
Yeah.
good way.
Yes.
Yeah.
Yeah.
And
Yes, these problems, like as I have already said, I am also going through those problems. So I think till this point we have talked about why C is important, uh, how much C we should learn, how to develop project mindset, and you also have given very good example of how simple C programs. So how simple C programs can be made into embedded projects, right? So that will give a clear understanding of how memory is managed into the hardware, and how we can use arrays for or any data structure for embedded applications. So yes, so that these all things we have covered. Now I think let's end this video by understanding what kind of roles available in the market for embedded system engineer. And I think you have one post already made for this as well, and you can quickly give your insight on will AI have a major impact on embedded system roles. So yeah, with that, I think we'll conclude our discussion. This will be the last question of our discussion. So yeah.
Okay, yeah. So as you see on the screen, this is about the jobs related in embedded. One of the that many early career peoples have. Are there any jobs in embedded? Or if I learn this particular skill, where can I use it? Which role should I choose? Embedded, and in the starting of the video, I said embedded is a huge field. Huge field does not just mean in terms of learning skills, huge field also in opportunities. From software, from low-level device drivers to IoT, from I think even in embedded cloud, that area is also there. From low-level device driver programming, hardware engineering, every aspect is covered in the embedded. Embedded is huge. Just to give you an insight on the roles that are available, as you can see on the screen, we have embedded software engineers, firmware engineers, understand the difference between software and firmware. Firmware, that is pretty important. Firmware is dealing with both hardware and software, while software is just dealing with the software per C code of the embedded. Embedded Linux engineer. Now you're embedded as well as a Linux engineer. That's why we told Linux is also needed in this embedded field. Microcontroller engineer. It is a field where you explore about the microcontroller architecture, develop a design a microcontroller of its own. I mean, as per the requirements of your project. Embedded verification engineer, embedded validation engineer. This is a pretty interesting field of verification and validation. I think will be required a different session on what verification and validation in embedded industry actually mean, because that's how the software development cycle actually works, I guess, yeah. And in the medical devices, it is huge. It's spread out from aerospace, railway industry, cyber industry, medical, industrial. It's huge. It's spread out. You've also got control system engineer. This field does not. It's like you can't run out of opportunities in this field. If you find yourself getting lost in one domain, you can just one to the other field. That's not an issue. And as a beginner, you can start with embedded software engineer or embedded firmware engineer, embedded hardware engineer, different fields. But many you can check this document that's in my LinkedIn post, as you can see on the screen. It gives you a brief idea on what job titles you can search for. You can just go in the LinkedIn and search embedded verification engineer. You can find a role.
Yeah,
Embedded validation engineer. You can find a role.
I will add it in
Yeah.
the description, link for it.
Yes. Yes. Yeah. You can see that in the description as well. It's gonna be the field is huge. The opportunities are huge. You just need the skills. It's a multidisciplinary field. It needs lots of learning in the initial stages, but as you proceed, the burden is gonna lessen.
So yeah, there are many fabulous companies, embedded system startups available in IoT space, right? And as we are progressing, we have lots of applications of chips in our day-to-day life. The role of chip or semiconductor chip is increasing day by day, and as we are using more semiconductor chips in our life, around like all around us, I think the role of embedded engineer will increase automatically, right? Okay, yeah, that's it. I think we have covered all the basic things which are required to start as an embedded engineer.
Mhm.
If audience have any questions or they have any doubts, they can write it in the comment section, or we have our LinkedIn profiles. I'll add link to the LinkedIn profiles in the description as well, so they can reach out to you or me on the LinkedIn and they can ask us like whatever doubts they have. Like both Yash and me are happy to help you guys. And yeah, thank you, Yash, for participating in the discussion. I think many more to come, and it was very nice talking to you. And yeah, let's try to have more discussion, and let's try to learn from each other as much as possible. So yeah, thank you once again.
Thank you so much, Pranjal, for inviting, and it's been a great interactive session with you and with the audience. It's gonna be, I think, the comment section is gonna be a blast in some time as soon as this is released. Uh, and also, guys, you can contact, as Pranjal said, either of us in through any medium. We are always available on LinkedIn. So do like the videos, share it among your friends who are willing to join the embedded field. It's gonna be an interesting time when
Yeah.
you learn this embedded. Yeah.
Yes.